Hello, gorgeous EMF people. It is Saturday lunchtime. You don't want food. You want a further banquet of knowledge, don't you? Fantastic. We have got an amazing lineup for you. We are going to get straight on with it. As for those of you who were here yesterday, I am Thor, God of Lightning Talks, and I am here to keep time. So we are going to get brand new information for all of us in bite-sized 5-minute increments, starting with road trip.
Hello. Hi. Right, 20 years ago, I visited Genoa, and I went here, 20th of September Road. I thought that's a strange name for a road. That must be a really important date to have a road named after it. Well, yes, it is, but since then I've seen roads named after days that are a lot less important, like the day the market opened, or the water supply arrived, or the day a town was founded, or liberated, or bombed, or named as the most Portuguese town in the province. There's Women's Day, Children's Day, and so on, and this raised two questions. Why don't we have this in Britain, and which days of the year have roads? Well, I guess we don't do it because we write addresses like this, so the house number could get mixed up with the day number. The languages in the green box keep those two numbers separate, and it's a lot more common in those, but not so much in these, and the Americans get away with that, so really I just don't know. As for the second question, if you type something like Rue du 11 Novembre into OpenStreetMap, it gives you a list of roads with that name. So I wrote a script which sent some 20,000 queries asking for every day of the year with words like road, street, avenue, and so on in a number of languages. That found 335 days, but for the days it didn't find, I didn't know if that's just because I didn't use the right words. So I put this project on hold for many years. More recently, I've learned you can download the OpenStreetMap database, so I downloaded every country in Europe, extracted the roads, and went through looking for the names of the months. That found these 32,000 roads named after dates, and they do include every day of the year. You see that some days are important to one country, or a few countries, or just one region. Others are scattered around. The 8th of August even has a road in England on an army base. The most common date is the 1st of May. The least common is Pi Day, 14th of March, which has just one road in the database, although they do write the name 3 different ways. If you're wondering about 29th of February, that's second from bottom with 2 roads. Now, every year I go to the Maths Jam gathering, and I considered presenting this stuff here, but it just never seemed right to be saying all this unless I'd actually visited every day of the year, and that would be far too much effort for a 5-minute talk. But then 2 years ago, this guy, Adam, did a talk about the warning signs on bridges, where he did actually visit an example of each one. And as I watched this, I thought, right, the game's on, I'm doing this. So, what's the plan? I don't have to visit all of these dots, just one of those, one of those, one of those, and so on. And I'm not doing them in date order. So, here's the algorithm I use. You give it a seed, which is a start and end, and optionally anywhere you want to visit in between. First, it considers every 1st of January road, and works out how much distance it would add if it diverted via that road. And it picks whichever one adds the least, which seems sensible. It does the same for the 2nd of January, and the 3rd, and so on for every day of the year, which gives these 366 best options. And then it picks whichever of those adds the most distance. I'll explain why in a moment, but it incorporates that into the route, so now you've got a route with 3 nodes. Then it repeats the process. It works out how much distance it would add if it diverted this route to every 1st of January, and every 2nd of January, and so on for every day that isn't already part of that route. That gives these best options. Here's the one that adds the most distance, and look, it's Pi Day. And now I think you can see why we choose that one, because there's no point making little tweaks to the route in France and Spain if at some point we've got to go to Italy. It's better to make that big change now, and then get on with the fine-tuning. So we just keep iterating this process, adding more and more nodes, until we end up with this, which visits every day of the year. And when I first saw this, I was pleased at how short it was. I knew I'd have to go there, and there. Zaragoza's got the only sensible 2nd of January, and Portugal's got loads of good stuff, so really, you can't do much better than this. I'm happy with this algorithm. What I'm not happy with is the database. In some places, it's out of date. Look, this road was called 19th of January 12 years ago, but not anymore. In other places, it's just wrong. It lists all of these as 25th of September, but really, the top 2 are the 28th, and this one's April. So I made a rule that I wouldn't allow any roads into my plan unless I'd seen recent photographic evidence of their name. And that caused a problem here in Zaragoza. The route visits 7 roads in that city, including 20th of December Walk. I searched everywhere online, but I couldn't find any photos of this sign, so I couldn't use it. I'd have to pick a different 20th of December, which means Romania. I need to visit this road instead of the one in Spain. So we use a seed that has a start and end, and that road. Run it, and you get this, which has problems. It goes across the sea, it goes to places I don't really want to go. So let's just get rid of all those grey dots and try again. Better, but if I'm going through Germany, I want to see 17th of June Street in Berlin. I mean, look, how could I ignore this? It's even got free parking. Include that in the seed, and you get this. Now, if I'm driving from there to there, I'll actually go this way, so to let the algorithm know that, we'll pick a road here and put it in the seed, and then let's forget that part and just make the whole thing a closed loop. Okay, now I just need to check all these roads one by one, starting with the rarest. If I'm happy with one, I include it in the seed. If there's a problem, then I search for an alternative that I do like, and I include that. Sometimes I include interesting places like this, where the 2nd and 3rd of March meet each other. By the time I'd finished, I had this, which is doable. So I started in Brussels with the 11th of November and went round clockwise across Germany into Poland, and then on into Slovakia, Hungary, and so on. There's Pi Day, and it was all going well until I reached the Costa Blanca, 29th of March. There it is on a map. There's a 2-year-old Google picture with 2 signs confirming the name, but when I got there, it had been changed, which worried me because that was a rare date. There were only 8 of them. Luckily, when I checked the map, I saw that 2 of those were still ahead of me, so I tweaked the plan to go down to Seville, where I found this replacement 29th of March. After that, there were no more major problems. I just followed the plan all the way back to Belgium. There's my completed route. It's about 13,000 kilometres and took me 7 weeks. And here are the roads that I visited. These are January, February, March, and so on. If you want to see these again or download a calendar, you can go to this web address. Thank you for listening.
5 seconds. Very well. All right. Did you get all of that? 5 seconds to spare. Very well done. Next up, for your delectation, we have From Data to Insights, the Power of Data Engineering.
Hello there. Right, first up, my name's David, and I'm a data engineer. But what's a data engineer? Well, yeah, someone who has technical errors. There we go. So, first of all, let's think about how Let's think about how organizations tend to organize their data. We organize data to make it useful for whatever it is we thought we were going to do with it, which means we end up with something that looks a bit like this. So we've got lots and lots of data that's all segmented, it's all chained up. If it was a library, there'd be lots of books, they'd all be chained to their shelves. That's great if I just want to get data from one book, but a real pain if I want to get from 2 books and they're at opposite ends of the library. And on top of that, it can actually get a lot worse. So as our systems get more complicated, we start to split out bits of the systems that do different things. So imagine I'm running a weather service. You've all seen lots of slides about the weather up on this screen earlier today. So, you know, I have data for all the different places. But wind data, rain data, they're very different, so I might split them out. All of a sudden, I've got a data set that looks a lot more like this, so that's cool. I've got like all of the wind data in those white books there, and all the rain data in the blue books, but it's really difficult to like get at all of it at once. Gets kind of harder. And this is kind of where data engineers tend to come in. Most companies get to a point that looks something like this. Data scattered everywhere. You can group bits of it together, but not all of it. So what do data engineers do? Pretty much, they start building these. We start taking all of the data we can, making it into into a catalogue that lots of different people can start to use it to understand, well, whatever they need to understand. So, yeah, that's pretty much what a data engineer does. Yeah, if you have any questions, come and yell at me afterwards. Thank you, folks.
I've got to say, you lot are very well behaved. Loving the timekeeping. This is making my job.
What did you need for 2 minutes more than I do?
Pay it forward. Love it. All right. Our mission to reduce wasteful single-use cups.
Hey there, how you doing? I'm Theo from Lava Labs. Rory and I founded a little venture that we're trying to, take global now. So we, as I said, Lava Labs, we started with the problem of disposable coffee cups. You might know this, but 2.5 billion are thrown away every year in the UK, but less than 0.25% are recycled. It is terrifying. So, why is that a problem? Well, this problem is what is the solution to that? Well, the solution we think is the reusable coffee cup, if that makes sense. 69% of UK adults already own a reusable, but less than 3% are regularly using one. So why is that? Well, we kicked off a few years ago and we asked 160 coffee shop customers why that is. And it turns out they're a pain to carry around, but also having to keep them clean is a real pain. No one likes washing up. The other thing is in the office, for example. So companies everywhere are getting everyone to use reusables. Great. But are they actually really considering the whole picture? The problem is, if you look at the life cycle analysis of these reusable coffee cups, a big part of that process is how you wash them. Unless you're washing them efficiently, you really might not be doing any better for the planet. For example, if you're hand washing, you might be using a litre of water each time. 1 cup equals 1,000 litres of water maybe a year, and that can really, really, really add up. So we thought for a few minutes, several years ago, we think there's a solution here that's needed. Something that combines the efficiency and hygiene levels of a dishwasher with the speed of hand washing. And that's what we've been working on for the last few years. Now, I did have a nice video on this, but it's a PDF, so it won't show. But essentially, we've built a device that can efficiently and very quickly wash reusables. And these go from coffee cups to pint glasses, as you'll see in the bar today, or, of course, anything, really, that counts as reusable. It uses an incredibly small amount of water and an incredibly small amount of energy. It's also built for customers to use it themselves, which removes a lot of staff labor time, as you can probably imagine. So really, we think this is the solution to how we can get to a really good point with reuse rather than an inefficient way. It's built for cafes, venues, workspaces, anywhere you can really think of where you might need to just clean your cup. Now, I was actually going to more talk about how we've got to this point over the years. I think that's probably a bit more of interest. So we started off about 2019 with some experimentation. We were just literally blasting some steam into a cup, see how quickly it would work. And it did a pretty good job. We then managed to build a sort of minimum viable product, like a lot of the things around here, something that a user could actually use and was friendly. Again, it cleans a cup in 15 seconds with minimal energy and water use. It's, hasn't changed. We then moved on, as we got actually more into the market, we discovered there is actually something here. So we built a slightly nicer prototype and then partnered with the contract caterer Sodexo to really try it out. So as you can see here in a cafe, this led us to actually be able to raise some money. It took us back to the drawing board. So then we actually did a load of testing in the labs. How clean can we get this cup? And as you can see here, we took some image data, run it through a program, and we got some scores. And that allowed us to really refine that steam, nozzle, heat, all those variables going into one to really make it work. And the result being is that we've now got a really nice, almost end-use prototype, the one you will see in the bar if you want to come and rinse your pint glass. And now we're actually heading towards our production unit this summer, which is very exciting, and really keen to just chat about it if anyone fancies coming having a chat. And that's us really, but the whistle-stop tour of how to take something that was on a workbench for 5 minutes to an actual product. So thank you.
Okay, who wants to spend the next 300 seconds of their life learning something new? Of course you do. Very appositely, keeping time with bead.
Hello. Hello, my name's Phil. This is part one of a longer talk, which I'm trying to get ready for October. Thank you for indulging me. So a bit more specific, we're here, it's Saturday, the 1st of June in 2024, Anno Domini. All of these are fairly arbitrary labels which somebody else chose for us. Saturday, June 2024, my name. All of these work by convention, but there are alternatives. It could be Saturn's Dag, the first calends of Cancer in the year of the world, 5784. You might not think of Bede as a mathematician or a scientist. You might not think of Bede much at all. Bede was a 7th century monk who lived in Northumbria near Gateshead. I don't know whether to call him an astronomer or a historian or a teacher or an author, so I'm just going to call him a polymath. He wrote about 40 books, articles, documents. The two which are of interest are De Temporibus, On Time, which was so popular he wrote a sequel, De Temporibus Rationae. If you really like this stuff, here is the translation by Faith Wallace. I can't read it in Latin. He's really, really obsessed with knowing when Easter is. That's the religious overtones of what he's trying to work out here, which involves predicting the date of future full moons, and he's quite interested in advocating that AD is the correct way to number the years. There are some alternative epochs. You could have the start of the world, Anno Mundi. Anno Domini is the one that we traditionally use, the year of the Lord. Slightly offset by 27 years is Anno Passionis, the year of the Passion, the death of Christ. The founding of Rome, that could be a starting point. Or regnal years, like if you look in old parliamentary documents, it'll say 1 Mary 3, the third year of Mary's reign. My favourite are the apocalyptic ones, which count upwards towards the end of the world. Some places say there's 6,000. Oh, it's an interactive talk, so you get to answer some questions. How long does it take the Earth to rotate once? Wrong. It's 23 hours, 56 minutes, and 4 seconds. This is because... Could I have a volunteer on the back row just to stand up, please? That's all you have to do, stand up. Thank you. So, if I'm the Earth, I'm rotating. But I'm not just doing that because I'm going through space like this. So when I'm pointing back the same way I was pointing a day ago, I have to rotate a little bit more. So one rotation, and then to the sun, it takes 4 minutes longer. How many times does the Earth rotate in one normal non-leap year? Wrong. It's 366, because I'm counting it from my point of view. That's 1 and a bit, but I did the and a bit. And if you add those up the whole year, you get 1 extra revolution. How much time have I got? Cool. This is the difference between synodic and sidereal timekeeping. Is it relative to the sun, or is it relative to the constellations, the heavens, which are fixed? Fixed. So here we go. If we are very, very specific to 3 decimal places, the lunar month is 27.322 days for the moon to get back to the same point of the sky, or 29.531 days between the full moon. The full moon is the important one for Easter, so we're going to use that. Remember, in the 700s, the Gregorian calendar had not come along yet, so we didn't have the slight adjustment to the every 100 years leap year rule, which means you just get 1 in 4 are a leap year, or 365 and a quarter days on average. As you can see, we can't get much overlap between 29.531 and 365.25. They don't divide very well. So if you're trying to make a repeating calendar into the future that has some sort of repeating pattern, how can I write this down and say when Easter is going to be 80 years from now? This doesn't help you. So we can start to multiply out and say, okay, well, can we find a reasonable overlap? And when we get to 8 solar years, it's pretty close. It's nearly 99 lunar months. So maybe we get away with that. There are some calendars which use an 8-year cycle. But imagine that table goes on. Well, 11 or 19 or 84-year cycles, they get pretty close. So the number right at the end is like the error bar on this calculation. You can see the best error bar is at 19-year cycles. This is the one that Bede is advocating for in the book. So that's the one we're going to go with. That means that every approximately 3 years, we're going to have to insert a lunar leap month. Why? Because if you do 12 lunar months, you haven't filled up the whole year. So you have to intercalate an extra month in. These are called the embolismic months. Embolism in medical terms is a blockage. Embolismic month is an additional month that you stick into the lunar calendar to keep it in line with the solar one. And here are some funny words that other people used to use. So the Anglo-Saxon names, he goes through all the different comparisons of Egyptian, Macedonian calendars, but the names of the months in Anglo-Saxon are the most amusing. I'll try and tell you what most of them mean. So you've got January is Julie. This is a lunar calendar, by the way. February is the Sol Monath. Sounds a bit English. March is the Hreth Monath. April is the Easter Monath, yeah? May, the 3 milky, because you can milk your cows 3 times a day. June is called Lithia, and July is called Lithia. Why not? August is the Woad Month. September, the Haleg Month. October is the Winter Philith. Sounds familiar. This one's a bit morbid. November is the Blood Month, which is something to do with sacrificing your cows. And then we've run out of names, so back to Julie again. We repeat that. I know what you're thinking. what do we do with the embolismic month in those years? Well, we put it in between Lithia and Lithia. Can you guess what it's called? Lithia. So those years are the Trilithia years. If you would like to know any more about this, there is another talk about calendars and movable feasts at 4:50 today on stage B. And if you really like this stuff, the translation from Faith Wallace is well worth the read. Thank you very much.
Thank you. Have you got... All right, thank you very much. That is our roster for today. A lovely plate of small but perfectly formed sweet treats, the petit four of EMF Talks. A small housekeeping announcement. I'm delighted to announce that the captions have been restored on the screen. So, yeah, you can scan the QR code and listen to, read back over everything that these wonderful people have said, plus all the rubbish that I've been spouting. If you would like some more of this, we are back here again at 11:40 tomorrow. Otherwise, have a lovely rest of the afternoon. Thank you very much.